x1 y1 is changing up with respect to the screen. So there are two things. So these are the 2 points. These are the two things that account for the offset. So we will have an offset x and an offset y to screen x of item dot from x. Then you have to screen y item dot from y. Then to screen x item dot to x and to screen y. Right now this is spanning. We can move the entire thing anywhere we want to. And yeah, this is working the way we want. Now so first of all, the maps are ready. What I've done here is that I have written a script called generate points.js where I'm hitting onto an endpoint and getting the data for latitude and longitude. I mean, I'm just getting the route from one point to the other. So these are the points that I'm getting data for. And along the route, whatever latitude and longitude I'm getting, I'm just connecting them and creating a graph, and that graph is this one. So there are lots of points and we will need more data for creating a robust map. So now this is done. The BFS is working fine, everything is working fine. Now the next part that we want to add is the panning and zooming functionality. So if you look at Google Maps, when you click and drag, you can pan around. Along with that, you can also, when you scroll up and down, you can just zoom in and zoom out. So this is the function that we want to add. So how are we going to do that? So the most important part uh, here is that we need to realize that whenever we are working with a canvas, so this is the canvas. Let's say we have a point, an object, a point. Let's say this is the point, and if this is the point that is x1 comma y1. So this is the point x1 comma y1. This on the screen, the point is given the place as x1 comma y1. So this is the address of the point. But whenever we pan, so what happens when we pan? So when I'm panning this, what happens is the position of it's not the canvas that is moving. We might think of this as a window behind which there's a canvas and the canvas is moving. So the canvas is at rest, canvas is not moving. What is moving is the point. So the point that is moving is according to is does depend on the amount of pan that I'm doing. So it depends on mouse move. So we are having the event listeners that will be mouse move, mouse down. So when we press down, we will have panning set to true, which means the we will let the application know that we are in the mode of panning. And when we are in the mode of panning, whatever will be the changes, whatever will be the delta from during panning, that will be taken care of and then added to x1 y1, and its position will be changed. So initially, whenever we are creating a map, the position of every point is going to be x1 comma y1, which is the initial position. And whenever we pan it down, up, or anywhere, what happens is the position x1 y1 is changing up with respect to the screen. So there are two things. There's a true position. True position is the one which is assigned at the start of the application, and there is a screen position that has nothing to do with true position. So screen position depends on the amount of uh, pan and the scale amount user has scaled up to. So this is how these are the two things that we will be taking care of. So the two other variables that we will be taking care of is the offset and scale. So what is an offset? Now, whenever initially when the map is created, you have x1 y1 at x1 y1. But when you try to pan it up, down, or anywhere, now at this position, the x1 y1 has changed to let's say something else that would be x2 y2. So this x2 y2 has some, and along with x1 y1, all the points on this plane have changed their position to some different position, some different thing. And what is that different thing? It depends on the difference of x2 minus x1. What is x2 minus? So this difference of x2 minus x1 is called as the offset. Let's say this point has moved from x1 minus x2, which means that the delta x is x2 minus x1. So every point on this plane, be it any of those, all the points will face a delta x of x2 minus x1. Along with that, all the points on this plane will face a delta y of y2 minus y1. So what this delta is called? This delta is nothing but the offset. So the offset will offset, yeah, so these are the 2 points. These are the two things that account for the offset. So we will have an offset x and an offset y as well. And the offset x and offset y will set the new position for x1, y1. The true position will be same. True position will be same. And this is our screen position that will be calculated upon the offset and true position. So it depends on the offset. Initially, the offsets will be zero, so we don't have to care about that. The formula will take care of that. So how this formula will look like? So whenever you have to calculate x2, what you'll have to calculate is x2 equals x1 plus offset of x, right? It will be x1 plus offset of x into offset of x divided by scale. Now, why this scale has come up here? Now, let's say we have this arrow. Okay, so let's take a new line. On this line, we have this point as x1 comma y1 and the other end as x2 comma y2. So in this case, we have x1 comma y1 and x2 comma y2. So in this case, what happens when we zoom in? So as I try to zoom in, what happens is the position of x1, y1 is changing. Although their sizes are changing, yeah, that is a different thing, but their position is also changing, which means that the the screen, the x2, which is the position, which is the x component on the screen, depends on the x1, that is the true position, along with the offset as well as the scale. So whenever I'm increasing this, the scale is, as I'm increasing, x1 is decreasing because the top left corner is 0 comma 0. It is coming closer to 0, which means x1 is decreasing. So scale is inversely proportional to the true x2, which means that if scale increases, the screen position of any point will start decreasing. And yeah, so that is how it is going to be. So, and also we'll see further when we will be implementing the zoom in, zoom out thing, we will see how this is going to work. So for now, this is how it is going to be. So let's do that in our application. So we will be using here references only. We will be using the useref hook only because we can't use useState, because useState takes a lot of time to change state variables and we won't see that instantaneous output on the screen. Along with that, one more thing that we will be doing is whenever we are panning or zooming in, whenever we have this handle mouse move, the mouse move event listener or mouse down event listener or any of these event listeners, for every moment that we are moving, we will get the value of the offset is going to change, and for every moment what the value of offset is going to change, and for every moment what we are going to do is we are going to clean the entire canvas up and redraw the canvas at a new position. So for every point on the canvas, every line that we have drawn on the canvas, every point that is already present on the canvas, what we are going to do is we are just going to remove all these points and write and draw these points again on a new position that would be x2 comma y2, or the position that depends on the offset as well as the true position. So that is the difference, that is something that we are going to do. So to redraw all of these things, we need to keep a track of the original points, the true points that we have. So we have to keep a track of this true position. So for that, we will create a new array called as history that will do the thing for us. So whenever we draw a line over here at any place, we will just add it to the history as well. So history dot push, let's add from x From x would be start coordinates dot x. From y would be let's say start coordinates dot y. 2x would be and coordinates dot x, and 2y would be and coordinates dot y. So this will keep a track of the history. Once the history is kept track of, you can implement the redraw function. Okay, so that is a different thing. Now let's declare all the other important references. So that is offset x, use ref 0, const offset y equals use ref 0. Scale, we will be setting initially the scale to 1. And apart from this, yeah, so this is all that we need. Also, let's add the event listeners on mouse down, handle mouse down. Then you have on mouse move, handle mouse move, on mouse up equals handle mouse up. So these are the things that we have. Along with that, we will declare a state variable panning, comma set panning equals use state. Initially, it is going to be false. Now let's implement these functions. Handle mouse down. So for handle mouse down, we will send an event. First of all, event dot prevent default. Yeah, so event default. Now the next part is that set panning to true. Once panning is set to true, I think yes, we are done. And along with that, we also have to keep a track of the cursor position where we had clicked, because whenever we pan, we need to find the offset. The offset is x2 minus x1. So if I'm panning this much, if I'm panning, let's say if I'm panning from here to here, I need to have this initial point as well as this final point, after which I can calculate the offset, which is the difference of these two. So for that, we will also keep it. And the most important part is whenever we are moving continuously, we need to change the offset continuously. We need to have this effect. We don't want to pan first and then see the effect at the end. We want to have this instantaneous effect. So for that, we will declare two more variables, cursor x and use ref 0, const cursor y. Along with that, we will also be having a priv cursor x. This variable will be important during the handle mouse move function. Priv cursor y equals use ref 0. Yeah. So these are the things that we have. Now we have set panning to true. Now let's go to const handle mouse move equals event. Here also the same thing. Let's prevent default actions if panning is set to true. First, okay, so when we click on the mouse, I also want the cursor x dot current to be set to event dot page x and cursor y dot current to be set to event dot page y. So event dot page x and page y will give the x and y coordinate of the point where we have clicked. So and also I'll set the priv cursor as well. So yeah, this is wow. This is how the things are going to be. Now, if it is panning, the first thing that we will be doing is changing the offsets. So first, okay, so offset x plus equals offset x dot current plus equals. mm, so the new offset will depend upon event dot page x minus priv cursor x dot current by scale. So this is how the offset is going to look like. It simply is this formula. The formula. Okay, so this is the formula that we are using. Initially, we had some offset. We are changing that offset now. So if it was zero, it will be handled accordingly. So no worries about that. Page y minus priv cursor y dot current by scale. So this is how we are going to do. Offsets have changed. Once the offsets have been changed, the next part would be, okay, so for every iteration, I want to set priv cursor dot current as event dot page x and priv cursor dot current equals event dot page y. So the handle mouse move is done. The last one would be handle mouse up event. I'll just prevent default and also redraw canvas. So what is this redraw canvas? This was what we had discussed. We need to clean the whole canvas up and draw the points on new positions. So we will also implement a function called as redraw canvas. So in redraw canvas, what we are going to do is for const item of history, for every element in history, what we are going to do is we are going to draw the line again. So we'll call the draw line function with all of these parameters which contain, okay, so the parameters that will be going here uh, would be would be the um, would be the coordinates of the screen. These are not the true coordinates. So what we have saved here is the true coordinates. Okay, where we have saved it. Okay, so in the history, what we have saved is the true coordinates. We need the coordinates of the screen, which depends upon the offset and scale. So for that, we will have to create some functions that would give us the to screen x and y. So const to screen x, what we will give a true x over here, and it will be returning. So the screen x is similar to this x1 plus offset divided by scale. So it would be true x plus offset of x dot current by scale dot current. Okay, similarly, we will have the screen to screen y offset y dot current and yeah, scale dot current. Yeah. So this is done. Now in the draw line function, we will take to screen x of item dot from x. Then you have to screen y item dot from y. Then to screen x item dot to x and to screen y item dot to y. So this is the draw line function and it will just redraw the canvas. Before that, we will also have to get the context and clean the canvas. Yeah, so context dot fill time, I guess. I'll just check the code here. Leave the canvas HTML. So fill style context dot clear rectangle. So context dot clear rectangle 0 comma 0 comma canvas width, canvas height. Okay, so that should work. Okay, so there is some problem here. Okay, so okay, so this is the mistake. We had to add scale.current. Let's make sure that we have added current everywhere because it's a use ref. Still it's not working. Okay, now it's working. The problem, okay, now it is working, but the problem is that it's not. So if we just put it here, yeah, so now this is working fine. And we will also add another one, mouse out. We'll handle mouse out. So if your mouse goes out, const handle mouse out equals event uh, set panning as false. The same thing here, set panning as false. Fi- Fine, now this is panning. We can move the entire thing anywhere we want to. And yeah, this is working the way we want. Now